Welcome back to the next memory map on phenol chemical properties. Let's continue to understand the next chemical property of phenol, that is electrophilic aromatic substitution. What do we mean by this? Here, the OH group which is attached to the benzene ring activated towards electrophilic substitution, and it is going to direct the incoming group to the ortho and the para position. Why does that so? Because the negative charge is present here, and that can be understood by the resonating structures of phenol which we studied previously. Under the electrophilic aromatic substitution reaction, the first that we are going to study is about nitration. There are two types of nitration reactions shown by phenol. Let's take up one by one. Under that, the first one. Phenol when treated with dilute nitric acid. Point to remember. Treated with dilute nitric acid at a low temperature of 298 Kelvin. That means around 25 degrees Celsius temperature. Phenol will yield a mixture of orthonitrophenol and paranitrophenol. Let's look into the reaction equation. Phenol C6H5OH treated with dilute nitric acid at about 298 Kelvin temperature gives isomers orthonitrophenol, paranitrophenol. For the phenol, NO2 is attached to the ortho position, second carbon atom position, therefore orthonitrophenol. And in the next isomer we see this nitro group is attached to the para position, fourth carbon atom position. Both will have the same molecular formula as C6H4OH NO2. Here a very important point to remember is ortho and para isomers, whatever the product that we will obtain by treating phenol with dilute nitric acid, if they have to be separated, we can do so by steam distillation process. Why? Because orthonitrophenol is steam volatile. Very important point to be registered by the students. Orthonitrophenol is steam volatile, means it is easily evaporable just by passing the steam. Why is orthonitrophenol steam volatile? Because it contains intramolecular hydrogen bonding. What do we mean by intramolecular hydrogen bonding? Hydrogen bonding existing within the same molecule is intramolecular hydrogen bonding. If any molecule is having intramolecular hydrogen bonding, then it remains as a separate component or a separate molecule. They will not cause association, thereby easy to break, and they can be easily brought to boiling condition. Therefore, their boiling point will be lesser, which is what is indicated here as steam volatile. Now, what is the case with respect to paranitrophenol? That means nitro group present attached in the para position or the fourth carbon atom position. It is less volatile. In comparison with orthonitrophenol, paranitrophenol is less volatile. Why? Because paranitrophenol is having intermolecular hydrogen bonding. That means hydrogen bond exists between two different molecules. As a result, each molecule is bounded to another molecule, and this is what we call it as association of molecules. If molecules are associated, more heat is required to break this hydrogen bonding, and then only the liquid can be brought to its boiling point or to the boiling condition. Therefore, orthonitrophenol is the first compound which will be separated by steam distillation. This is a very important point to remember both from entrance point of view as well as board exam point of view. Now let us understand the second type of nitration reaction. Phenol, when treated with concentrated nitric acid. Earlier case was dilute nitric acid. Now we are treating it with concentrated nitric acid, or else we also call it as fuming nitric acid. Phenol is converted into 2,4,6 trinitrophenol, which is also called picric acid. Picric acid is a very popular name. In fact, picric acid is a powerful explosive. Now let's look into the reaction equation. Phenol C6H5OH, when treated with concentrated nitric acid, we observe a trinitro substituted product of phenol. Where are the nitro groups attached? With respect to the second carbon atom and fourth carbon atom and to sixth carbon atom. Therefore, we call this compound as 2,4,6 trinitro, otherwise it is a phenol, trinitrophenol, which is popularly called picric acid. Now, picric acid is a yellow crystalline solid. Another important point to remember, it is a yellow crystalline solid. Trinitrophenol is a strong acid. What is the reason? Which we have learnt previously also. Because this 2,4,6 trinitrophenol, as the name is indicating, there are 3 nitro groups and each nitro group is electron withdrawing in nature. So, if more number of electron withdrawing group is present, obviously the acidity increases as it facilitates the release of hydrogen ion. So, 2,4,6 trinitrophenol is a strong acid. Another point that we can remember associated to this is picric acid can be obtained by treating it with nitrating mixture. What is nitrating mixture? Concentrated nitric acid and concentrated sulfuric acid. We call it as nitrating mixture. So when treated with nitrating mixture also, we will be getting this picric acid or 2,4,6 trinitrophenol. Each question on nitration will be for 2 marks. Students are advised to look into the question properly, whether the question is with respect to dilute nitric acid or whether it is respect to concentrated nitric acid. With concentrated nitric acid we get trinitro substitution of phenol as the product. With dilute nitric acid we get ortho and para isomer as the product. Now let's understand the second type of electrophilic aromatic substitution, that is halogenation. Again, halogenation we will need to understand about 2 types of halogenation. The halogenation that we are going to carry out here is the process of bromination. Now, phenol when treated with bromine in a low polar solvent like chloroform or carbon disulfide at a low temperature, say about 0 degrees Celsius, we will get ortho and para bromophenols as our product. They are again isomers. Let's look into the reaction equation. Phenol C6H5OH when treated with bromine in an inert solvent or a low polar solvent at about 0 degrees Celsius or 273 Kelvin temperature, it gives us an ortho and a para bromo substituted product of phenol. In the ortho position we have Br here and in the para position we have Br here. Therefore, this compound is called orthobromophenol and this is called para-bromophenol, and both the isomers will have the molecular formula as C6H4OH and Br. Now, here is a point of note to remember in association with this. Due to high activating effect of the OH group, which is attached to the benzene ring in case of phenol, the polarization of bromine molecule takes place even in the absence of Lewis acid. Therefore, even without using Lewis acid like FeBr3 or AlBr3, we can carry out the process of bromination just with an inert solvent, which is not the case with respect to benzene ring. If we have to carry out the bromination of benzene ring, definitely we should use Lewis acid like FeBr3. This is a very important point to remember, which will be a question for even give reason. Next type of bromination is phenol when treated with bromine water. Condition to remember is bromine water. It will form a white precipitate of 2,4,6 tribromophenol. Earlier case of bromination was with respect to low polar solvent. Now this is a case with respect to bromine water. Very important reaction, direct question for 2 marks. Let's look into the equation. Phenol C6H5OH plus 3Br2. Why are we using 3Br2 here? Because this bromine has to get attached in 3 positions of the benzene ring. Not only that, the excess 3 more bromine has to react with coming out hydrogen from the benzene ring and it will form 3HBr. So therefore we have to take 6Br, which is indicated as 3Br2. So what's the product we are going to get? To the phenol in the second carbon atom position, fourth carbon atom position, sixth carbon atom position, Br gets attached. Therefore, what is the name of this molecule? 2,4,6 tribromophenol, which is actually a white precipitate, and it is also associated with 3HBr formation. Whether you write 3HBr or not, that's immaterial, because the point of focus here is obtaining 2,4,6 tribromophenol, which is a white precipitate. So these are very 2 important reactions with respect to electrophilic aromatic substitution reactions of phenol. You need to go through all the memory maps on chemical properties of phenol to get an in-depth understanding about it.